Hi everyone, I'm excited to talk to you today about Hedera's EVM journey on equivalence. So a little bit about myself, my name is Essilfie-Conduah. I'm the senior software engineering manager at Swirlds Labs. We're in charge of building out the smart contracts on the Hedera ecosystem. And one thing I really like is when architects are able to take a really complex topic and present it in a really simple interface. And I think this is really important for the Web3 and the smart contracts industry. And so for me, when you look at the EVM and you consider it as an API, I think this is a really powerful way to bring in simplicity to smart contract development. So let me tell you a bit about Hedera. Hedera is an open source proof of stake and enterprise grade ready network. We do 10,000 transactions per second, and this is when we throttle, meaning we have tested more than 10,000 transactions, but this is fine for everybody right now. Those transactions are also cheap, so you can submit a transaction and pay as little as 1/3 of a cent to send cryptocurrencies across. Those transactions also come to finality in 3 to 7 seconds, and this is at one probability. So this isn't waiting around for more blocks. This is if the ledger accepted it, it's final and it's included. On the smart contract side, we do 15 million gas per second, and we actually emit blocks every 2 seconds. So this means 30 million gas every block every 2 seconds. We're also very proud of our small energy footprint, and you'll see here that the University College of London did an independent study and showed a couple of chains and their comparisons of how much energy they actually take. So that small little green block at the top is us. So let's take a step back. A couple of you will know the concept of a DLT, a distributed ledger technology. Blockchain is one of those. You may have heard that Hedera is not a blockchain, and I'm going to tell you why. In terms of consensus, a lot of you will know that in a blockchain, you have this combination or set of transactions, which you call a block. It has one hash that refers to the previous block and so on and so forth. And that kind of gives you the security, right? On Hedera, we use the hash graph protocol, and it's a little bit different. We don't use a linked list in terms of that chain. We use this data structure called a directed acyclical graph. What this really allows you to do is go along sort of multiple pathways within the graph going in the same direction. And instead of one hash, we actually take two. So if you take the hash of the transactions that you have on your node, as well as the hash of the transactions coming in from another node, and you add the signature, you get this really powerful thing where I can tell when you received your transactions, who you got it from, and when they told it to you. And this is what really results in us being able to come to consensus really quickly. You might find, though, that this means that our ledger initially looks very different from many others. And when you think about smart contract development and the EVM, it actually results in some incompatibility. Unfortunately, the EVM makes a couple of assumptions at the network level on what Ethereum does. And so you have things like network properties, data structures, cryptography that leaks into the EVM as an API when it really shouldn't, which means other chains which aren't Ethereum that are trying to take it might have these issues. So at one point in time, we had to ask ourselves, do we want to do EVM compatibility or do we want to do EVM equivalence? Spoiler alert, we decided to go on equivalence, right? Our goal here is that we really wanted to make the experience for developers and users, seamless, right? We wanted users that are on other EVM blockchains to come over and have that same experience. We want developers to be able to copy and paste their code, use the same tools, and have no issues there. And so that's the goal that we sort of went along, and I want to tell you a bit about that journey. So I'm going to highlight a couple of node decisions that we made along the network, as well as things around security and just the workflow in general. So at the network level, we made a couple of decisions. One of the things that I want to highlight is that we changed our execution client. So we used to use Ethereum J, and now we use the Hyperledger Besu EVM client. And this is really a big testament to the Hyperledger and Besu team for their open source contribution there. And this is one of the big pivot points that allowed us to sort of pursue EVM equivalence there. We also decided not to reinvent the wheel, so we take the transactions as EVM clients and tools are used to them. So in the RLP encoded form, we take that, we wrap it, we give it to the network, and it processes it as you would. So we don't need to change anything or sort of fuzzle with anything. We also exposed the concept of blocks. We had them sort of innately, but there wasn't a necessity to sort of expose them, and so we do for these EVM clients. And we did a lot of work around improving our archive node and in sort of embedding things like contract logs, state changes, and the bytecode itself, sort of these expected data characteristics of an EVM client. Once we were able to do this at a network level, we were able to go a bit higher to the application level, and we sort of provided what we would say is an information bridge. We developed what we call the JSON RPC bridge, and it's really just an interface around the Hedera nodes that make Hedera look like an EVM chain. So all the expectations of API endpoints and characteristics are able to be brought through with the JSON RPC node. And so in this diagram, you can see sort of like the expectations of any other dApp, right? You interact with the dApp, you click on something, your wallet shows up. In this case, let's say MetaMask. It allows you to sign the transaction, and it goes to the relay. The relay takes that RLP encoded transaction, wraps it, gives it to our network. We submit it the way that we would expect it, but then internally we're able to extract that internal transaction, which is RLP encoded, and give it to the EVM client, and everything works for everybody. Everybody's satisfied. We also had to sort of improve our account interoperability. One thing I didn't mention was that the EVM relies on ECDSA cryptography-based accounts. Hedera at the beginning supported, I would say, a more stronger quantum resistant type, which was ED25519. But to bring that equivalence around, we had to support ECDSA-based accounts as well. But what's interesting is that on the EVM, an account is really just an address. It doesn't care whether it's been used before or not. But on Hedera, accounts are actually a bit more complex. And we innately have concepts around account abstraction, but also account security, which the EVM didn't have itself. So we had to add something called auto account creation, in that when you do interact with an account on Hedera, in the background, we automatically create it for you. The problem was that we were sort of doing the nice thing for developers and telling them that, hey, your account doesn't exist. But on the EVM, it didn't have that concept. So this is an example of one of those little issues. On one case, it's helpful to some developers. On other cases, it's a little confusing. So we had to fix that. We also had to relook at our tokens. On the EVM, tokens are really just balances within smart contracts. On Hedera, we looked at this and said, why should we limit users and developers' abilities to transact with tokens? So we actually have native tokens. And again, like accounts, they're more complex. They have certain capabilities that you can do in addition to ERCs. But the problem was that when you think of equivalence, people would think only of ERC20s and ERC721s, right? So what we did really there was to just wrap our tokens again, right? If you have a native token on Hedera that is fungible, you can treat it as if it was an ERC20. If you have a non-fungible token that's native on Hedera, you can treat it as if it was an ERC721. So from a smart contract developer view, it's exactly the same. You use the same interfaces. Your smart contracts don't need to be rewritten. You can bring them over from other chains, and it will work as you would expect. What this actually ends up in is a really powerful, I would say, hybrid DeFi environment, whereby you can choose as a developer, do you want to use ERCs or do you want to use native? Or actually, do you want to combine them? So it's really up to you. And that's one thing that we continue to do, right? Put the power in the hands of the developers and the users, choose it and do it how you like. We also took a step back to look at our security model. Again, we had taken certain steps to provide additional functionality, but also additional security around multi-sig scenarios. This was something that the EVM didn't necessarily understand. And so we had to take a step back, simplify, and also break that out. So what we did there was at the level 0, what we would say is that our smart contract executions follow the EVM model. That means things like the contracts and the accounts can only modify their own state or their own balance. We then go level 1 up, which is certain ERC considerations. And so you would think of approval and allowances. Those are concepts that we also add to the security model. And then finally, we'd say at the level 2 is where Hedera comes in and sort of it's extra multi-sig and other scenarios. And so we follow that. We also sort of embarked on increasing the transparency around smart contract execution. So within our Block Explorer, we added support for verifying your contract, also displaying the things like opcodes, really just giving users more confidence about the smart contracts that they're interacting with. And so this was about a year and a half embarked in terms of the engineering work. So we started around mid 2023, and around now I can say we've successfully reached a good point where most of the expectations around developers are valid, right? Whichever wallet you decide to use, whether it's MetaMask or others, whichever tools you decide to use, be it VM, Web3.js, Hard Hat, Foundry, these work as you would expect them to. We have, an anonymous wallet, faucet. We also have the ability to just deploy as you would expect. And so we're really proud of this endeavor. So now that we've sort of gotten to this point where we feel like we have a good equivalent story, some people might ask, what's next? We've already embarked on using MetaMask snaps, and these snaps allow us to embed that extra Hedera functionality that I said the EVM doesn't sort of understand. We can add it there. We're also looking to support dynamic token metadata soon. Currently, the Ethereum organization is getting ready to do the hard fork for Cancun next month. We're actively working on development then, and it should come out soon after. We'll also hope to expose more native contracts and services through our smart contracts. And also, you remember that I mentioned 15 million gas per second before. Again, that's something that we've throttled it to match Ethereum, but there's no reason that we need to keep it like that when we have other circumstances, right? So we'll look into that and increasing that number and really putting that extra power in the hands of developers. We also hope to embark on looking at signature verification and sort of, again, exposing that within smart contracts. So I know that was a rush. There's a lot of information in there, but over at the other side, we're at booth 105. If you want to interact with us, a couple of Hedera people around here too, if you have more questions. I do want to call out that if you do have dApps, smart contracts on other EVM chains and you want sort of funding, the HBAR Foundation is a group that you want to go to. They have funding and will be able to support you there. And maybe ask about the DREC Alliance, which is a collaboration between Swirlds Labs, Algorand, and others, which are looking at decentralized recovery across networks, be them for passwords, key phrases, etc. All right, thank you very much.